Okay, so this is going to be the Finding the Density of Regular and Irregular Shaped Objects lab. So this is part 1. First, you're going to need to fill in some of your blanks. For question 1, how is the density of a regular shaped object determined? Number 1, you find the volume by using the steps in part 1. It's on the next page, you'll see that there. Number 2, find the mass in grams using a triple beam balance. And 3, divide the mass by the volume and label your answer in grams per cubic centimeter. Okay. For number 2, how is the density of an irregular object determined? For number 1, you're going to find the mass in grams using a triple beam balance, so that's the same. And then 2, we're going to find the volume using the steps in part 2. We're going to divide mass by volume and label grams per cubic centimeter because our irregular object is a solid, so we're not going to use milliliters. So here's the part 1. These are the procedures that we're going to follow. First, we're going to get our regular object. That's going to be this cube. Then it says, using a triple beam balance, record the mass to the nearest tenth of a gram. Alright, so there's our cube. And here are our answers. We have 139.5. And you can see it's balanced out. So our mass is 139.5 grams. Now find the length, width, and height. Cool thing about cubes, all of the sides are going to be the same, so we just need to measure one of the lengths. Alright, so measuring one of the lengths, we can see that it is 2.5 centimeters. And we're going to write that for all 3 of our measurements. 2.5 centimeters, 2.5 centimeters, and 2.5 centimeters. Then they want to know, what's the formula to find the volume? Well, to find the volume of our cube, we need to take the length times the width times the height. And then let's find our answer. That is going to give us 15.625 cubic centimeters. Centimeters cubed. Now they want to know, what's the formula for density? Well, we know that density equals, and you can write it 3 different ways, mass divided by volume, or we can write density is mass divided by volume, or density equals mass divided by volume. However you would like to write it, they're all the same. So let's do that and find out what our density is. So we take our mass, 139.5, and we divide it by our volume, which is 15.625. We're going to round that to the tenths. So we're going to have 8 point, now the 9 is in the tenths. We have to look at our hundredths place value to see if this is going to round up or if it's going to stay the same. The 2, since it's smaller than 5, means that our 9 is going to stay the same. So we're going to have 8.9 grams per cubic centimeter. Now let's skip this part and go to the next part for our irregular object. The irregular object is going to be a marble, not a rock, because we had problems with the rocks last time. We're going to use a triple beam balance to record the mass to the nearest tenth of a gram. But look, there's a star there. So go to the star. Because a marble would roll off the triple beam balance, we got to do something different. So 1, we need to find the mass of the cup that our marble is in, and then we're going to find out the mass of the cup and the marble. Then we are going to subtract mass number 2 from mass number 1 to get just the mass of the marble. So there's the cup. Its mass is 23.5 grams. So the mass of the cup, 23.5. Now let's add our marble and see what that mass is. So with the marble in the cup, we are at exactly 44 grams. Okay? 44 grams. Now we're going to subtract 44 from 23.5. 44 minus 23.5. That gives us 20.5. So the mass of our marble, mass of the object, is going to be 20.5 grams. All right. Place water into the graduated cylinder and record the level. Well, we have put 50 milliliters of water in our graduated cylinder. Without splashing any water, place the irregular object into the graduated cylinder so it's completely submerged and record your new water level. So it's a little hard to see, but the marble is down there. We were at 50, which is here, and now we're up to this line, which is 58. So we went from 50 to 58 milliliters. Now it says the difference. That means you need to subtract 58 from 50, which is 8 milliliters. And that is going to be our volume. Our marble displaced or moved 8 cubic centimeters or milliliters of water out of the way to make place for it. Then the formula for density, again, you can write it the 3 different ways. Density is mass over volume, or density is mass divided by volume, or density is mass divided by volume. And we're going to go to the nearest tenth of a degree. So let's take our mass, which was 20.5, and divide it by our volume, which was 8. So that is going to be 2 point, and then remember we got to look at the hundredths. So there is our tenths, this is our hundredths. Since 6 is bigger than 5, that means our 5 is going to change to a 6. So we're going to have 2.6 grams per cubic centimeters. Okay, let's go back to this problem question 3. How does finding the density of a regular object compare to finding the density of the irregular object? Well, for a regular shaped object, we measure and multiply the length and the width and the height to find its volume. Then, using the mass, we complete the density equation formula. Now to find the volume of the irregular object, we don't do length times width times height. We are going to take a graduated cylinder to find the volume. And then we're going to take our volume that we found, and using mass, complete the density equation. So really, we just use 2 different ways to find volume of irregular and regular objects, and use that to calculate density. This ends part 1 of Calculating Density Labs.